Hello Pre-Calc BC and welcome back to another fabulous lesson. Today we are on day 2 of chapter 4 and we are still discussing the chain rule. We're going to do some more practice with it. We are going to skip number 1 though, so you can come straight down here to where we're going to talk about parametric curves. So parametric curves, if you recall, had an x equals and a y equals equation and there were t's in them. So when you find the derivative, you're really finding dx dt, the derivative of x with respect to t, and dy dt, the derivative of y with respect to t. But what we generally want to find is dy dx, which is the slope of our tangent line of the curve. So how would you do that? Think back to what we did yesterday when we found dy du and du dx, and we found that when we multiply those together, we get dy dx, which is what we want. So what can you do with these two derivatives here in order to get this one? Take a moment to think about that. Well, if you said divide them, you would be correct. dy dt divided by dx dt. We go ahead and we rewrite this as multiplying by the reciprocal. Our dt's will cancel. And we should get our dy dx. That is what we are going to do in order to find dy dx when we're dealing with parametric equations. Let's give it a try. Find the line tangent to the curve defined parametrically by x equals secant t and y equals tangent t when t equals pi over 6. Alright, so first let's find dx dt and dy dt. dx dt, we're just taking the derivative of secant here, and derivative of secant is secant tan. So secant t tangent t. And dy dt is just the derivative of tangent t. Derivative of tangent is secant squared. Alright, and now I want dy dx, and so I will divide these. And notice we are putting the dy dt on top. So secant squared t over secant t tangent t, and then it will help if you simplify this. So we'll have a secant that cancels. So secant t over tangent t. And actually you can simplify this further because secant is just 1 over cosine. And tangent is sine over cosine. So really your cosines cancel, and you're just left with 1 over sine or cosecant. Okay, so that's dy dx. This is my slope. And no, you don't have to simplify all that, but it is going to be easier when we go ahead and we plug in pi over 6. Okay, just saying. Alright, so now let's find our slope at pi over 6. So I have y prime of pi over 6 equals cosecant of pi over 6. And this is just saying take the sine of pi over 6 and then do the reciprocal of it. So sine of pi over 6 is 1/2, and the reciprocal of 1/2 is 2. So that's my slope. We still need our point. And our point is just going to come from plugging in pi over 6 to t, and that will give us both our x and our y. So let's do that now. X equals secant of pi over 6, and y equals tangent of pi over 6. Secant of pi over 6 is just the reciprocal of cosine. Cosine of pi over 6 is √3 over 2, so secant is 2 over √3, and tangent of pi over 6, oops, wrong way. Let me just write pi over 6 over here. Tangent is y over x, so it'd be 1 over √3, or √3 over 3. Okay, and so now we have our x and our y and our slope, so we can write our tangent line. Y minus 1 over √3 equals my slope is 2, x minus 2 over root 3. And again, you can rationalize or not. It's up to you. Okay, so there's my actual answer. Okay. Let's try one more like that. This time, though, we are going to find d dt of dy dx. And so essentially what that's asking for is the second derivative. It's going to be pretty exciting. Let's start, though, by doing this the same way we did before. We're just not writing a tangent line this time. Dx dt, that's the derivative of this guy. It's going to be 10t plus 1. That's using power rule. Dy dt, derivative of cosine is negative sine. And we want dy dx. So dy dx we divide. And we get this. Alright, so now we're finding d dt of dy dx. So what that means is we're taking the derivative of this with respect to t. And we're taking it with respect to t because we have t's in it. So d dt of dy dx is equal to, and now how do we find the derivative of this? Well, we're going to use quotient rule. So let me write that out for us. So that's d high low minus high d low all over the square of what's below. So u prime, okay, that's now the derivative of this guy. The derivative of negative sine is negative cosine. V, 10t plus 1 minus u, negative sine t, v prime. So derivative of 10t plus 1 is just 10 over v squared. And you can leave it like that. Probably the only thing that I would change, I would probably bring the 10 forward and make this a plus. So I'll just do that right here. So plus 10 sine t. And you don't have to do anything else with that. Ta-da! All right, go ahead and flip the page. This shows up, these types of problems show up a lot in your calc book. Given the table below, find the derivative at the given values. So we're going to start easy and then it's going to get progressively harder. Let h of x equal 2 f of x. Find h prime of x when x equals 2. So basically this is just saying take the derivative of this when x is 2. So that's just going to be 2. So I'm just going to say h prime of x equals, that would be 2 times the derivative of f. And so h prime 2, we're just going to now go ahead and plug a 2 in. And so f prime of 2, that's x is 2, we want f prime, so that's 1/3. And 2/3 is your answer. All right, next. Let k of x equal f of x times g of x. Find k prime of x when x is 3. All right, so we're taking the derivative of this, and that would need to be product rule because these two things are multiplying. So k prime of x. So first I'm just going to write it out like this. It would be, so f prime times g, so I'm just doing u prime v but with f and g here, plus f of x g prime of x. Now I'm going to plug in the 3. So I like to go one step at a time because otherwise I mess it up. But if you think you can skip steps, you rock it out. All right, f prime of 3. So x is 3, f prime is 2 pi. G of 3, g is -4. F of 3 is 3. g prime 3. So x is 3, g prime is 5. So that's a negative 8 pi plus 15 would be your answer. Okay. Let m of x equal f of g of x. This is actually chain rule because you have a function within another function. So when we take the derivative of this, remember we take the derivative of the outside part first, then we take the derivative of the inside part. Okay, so that's how we would do chain rule, and then we'll go ahead and we'll plug in the 2. All right, so that's our first step. And now we'll go ahead and we'll plug in our numbers. So notice we're going to have to do a little extra work because it says g of 2 to g of 2 is 2. I'll try to do this without scrolling. Times g prime 2. So g prime's over here, that's negative 3. But we still have another step because now it's f prime 2. So f prime 2 is 1/3. So I have 1/3 times negative 3, and that is negative 1. All right, 2 more. This guy right here, I'm going to rewrite as g negative 2x, or g of x to the negative 2 power. This will also be chain rule because we have two things happening. First, we have to bring our exponent forward and go down by 1. Then we have to take the derivative of the inside, which is g prime of x. And we're plugging in a 3. So I'm going to write this like this. This is g of 3 raised to the negative 3rd power. Okay. All right, let's see if we can find it. So I need g of 3 and I need g prime 3. G of 3 is negative 4, g prime 3 is 5. Now we just keep evaluating. So this is negative 2 over negative 4 to the 3rd power times 5. Negative 4 to the 3rd power, I believe, is negative 64 times 5. So that should be 10 over 64, which is 5 over 32. Last one. You have an option here. It's the same option you are presented with from yesterday. We can either bring this root g of x up and do product rule, or you can do quotient rule. It is entirely up to you. I don't know, I kind of just go with what I'm feeling. I guess I feel like doing product rule right now, so I'm going to do that. Especially since we actually need to evaluate this, like we need to get a number, I just feel like product rule will be easier. So I'm going to rewrite n of x as x, so remember this is g of x to the 1/2 power, and then g of x to the negative 1/2 power. All right, so now I'm going to do product rule. V plus uv prime. All right, so u prime, u is like my x here, is 1, and then that's staying the same, plus u, that's x, v prime. All right, now this v prime will be chain rule. Negative 1/2 comes forward, still a g of x, drop it by 1 to the negative 3/2 power, times, then we're taking the derivative of the inside, which is g prime of x. Now I'm going to plug in my 2. And I'm just going to get rid of that 1. So I have g of 2 to the negative 1/2 power plus x is 2, negative 1/2, g of 2 to the negative 3/2 power times g prime of 2. So really I just need g of 2 and g prime of 2 to do this. G of 2 is 2, g prime of 2, negative 3. All right, let's do this. All right, good news. Because this gets really messy, we are not going to simplify it. Do not simplify. So all I'm going to make you do, because you're probably sitting here like, oh, this is going to be horrible. We're going to plug our 2 in, or we're going to plug these values in, and then we're going to be done. Only simplify unless it tells you simplify completely. Okay, so g of 2 is 2 to the negative 1/2 power. If you want to write that as a 1 over root 2, you can. I'm not going to. And then here, I might simplify that. 2 times negative 1/2 is negative 1. G of 2 is 2 to the negative 3/2 power times g prime of 2 is negative 3. Right, and you can leave it like this. All right, if you want to go further and be like that, and then negative 1 times negative 3 is positive 3 times 1 over 2 to the 3/2 power. You can do that, but do not simplify. So here. Ta-da! Done!